Hello and welcome to the Slackware on vlog. If you're new to the channel, really this vlog is about the development of one of the oldest open source projects in the world, which is Slackware Linux, which has been around for over 30 years at this point. And this channel focuses on the development of the ARM port of that project, which has been around for about 22 years right now. In this vlog we cover kind of whatever comes to mind really, or whatever we're working on. Generally we focus on what it takes to build the operating system and the development and that kind of stuff, because that's where I spend most of my time working on the project, is either maintaining it or developing it. So that's generally what we focus on, but also other things as well. We might speak to some other members of the team, might speak to members of the community. On the very first series of the podcast, we spoke to a few people from the community who talked about how they use the project. So if you're interested in talking with the community and having your voice heard, just send me an email and we'll work it out. Now, in this episode, I'm going to continue working towards one of the roadmap goals, which is providing an installer variant, or spin as some people would call it, of the Slackware installer that includes the Raspberry Pi Kernel Fork packages, which is just really the Slackware kernel, or the Linux kernel, built from the Raspberry Pi developer's source tree rather than the Linus Torvalds version, the official one, and using the Raspberry Pi developer's kernel configuration. That's it really. There is a reason for that, and it's basically just because the support in the official Linus Torvalds kernel.org kernel tends to lag behind the Raspberry Pi development. It tends to lag behind the version that the Raspberry Pi team develop. So what that means is that occasionally the support can be unstable, or it can just be non-existent. So things don't quite work, or don't work at all, or work to some degree and then break. So for the Raspberry Pi 4, actually it's generally pretty good, and you can install Slackware on a Raspberry Pi 4 using the standard official Slackware installer images, and the kernel as well. But for the Raspberry Pi 5, my co-developer Brent's been working on that, and at the moment it looks like we need to use the Raspberry Pi Kernel Fork. So on the roadmap, I put this item to create a variant of the Slackware installer that really just, instead of using the standard Slackware kernel packages, it would instead replace them with the Raspberry Pi Kernel Fork, as I call it, version of it. So other than that, it's identical. In a previous video, we were collecting together the specification of a tool that will process the Slackware installer image and replace various components with the Raspberry Pi Kernel Fork versions and make a few other modifications. I haven't done that yet. I haven't finalized that specification, but what I have done is built Raspberry Pi 5 kernel packages in addition to Raspberry Pi 4 kernel packages, because there is a difference in the kernel configuration, which if you watch the last video you'll see what those differences are. They're actually pretty minimal, but they are important and significant. So I needed to create two versions of the kernel packages, one for the 4 and one for the 5. So that's one job done. The second job is that there are a few configuration tweaks that need to be made on the Raspberry Pi so that it works properly using the Raspberry Pi Kernel Fork packages, which basically means when you upgrade to these transition to these packages, there's no serial port access. You lose serial port as soon as the kernel boots, which to me is really unacceptable, because I use a serial port all the time for remote access, reinstalling, stuff like that. So to me it's kind of vital that we have that. So the second thing is, let's leave it at that. There's a serial port access, but it's configured in two different places. So we're going to fix that. And then the other is, if you use Slack package, Slack package is a tool included with Slackware to automatically handle upgrading your system. So it makes it really easy to keep a Slackware system up to date. The problem is that if you, by default, if you install Slackware, then transition to the Slackware to the Raspberry Pi Kernel Fork packages, when you do an upgrade, your system will revert back to the standard Slackware packages, and then your system won't quite work the same way. So as part of the post installation, we also need to blacklist or mask out the official Slackware kernel packages so that they don't replace the kernel, the Raspberry Pi Kernel Fork packages. Now, off on a tangent, that does mean that you need to manually handle upgrading a kernel yourself, and I have no plans to address that at all because, first of all, because I don't want to be honest, but secondly, because the whole point of the plan is not to. Ultimately, the end game for Slackware is that we use upstream sources, and so that means that the end state of any Slackware installation is that you use the official Slackware packages, which uses the official Linus Torvalds kernel in this case. So ultimately, once the support for the Raspberry Pi is in the upstream kernel, then hopefully you won't need to rely on these Raspberry Pi Kernel Fork packages as much or at all. Like in a Raspberry Pi 4, you don't actually need to. There are still some benefits, and that's just around the hardware support. But again, eventually all that stuff finally, over time, finds its way into the upstream kernel. So we will eventually get it. It's just a case of waiting. And sometimes you don't want to wait, or you can't wait. So it does mean that you need to manage the life cycle of the upgrades yourself. It's not going to be automated. I mean, you can automate it yourself by writing a script. It's not difficult, but you could pull them from the FTP site and then upgrade them. But that's not something that I'm going to get into. So before we get into it, so I just want to thank you guys for your support. The donations to the project go towards paying for the electricity for this stuff and buying new hardware. That's pretty much what it is. And ultimately what I want to do is upgrade the master build machine, or the main workhorse of the machine that does all the building. I want to upgrade that to an Apple M4 Mini if I can, because they are so fast. Even the Apple M2, I mean, it kicks the ass of the Honeycomb LX2, let's put it that way. And that's quite a nice beefy machine. So really I'd like to move to the Apple M4 Mini and run Slackware in paravirtualize mode. Just because it's faster. It's faster to develop. It means I make things happen faster because I get the results faster. I mean, that's pretty much it. It also means I don't need to I won't need to power a physical machine for stable releases, because I always like to have the stable release running on a physical piece of hardware. But in this case, what I can do is have a stable release running in a VM and just boot it up when I need it. So yeah, that's what I really want to do. So your donations go towards things like eventually buying one of those. It's not going to happen It's not going to happen for the foreseeable future because they're pretty expensive, but that's kind of where I'm going. And also it means that potentially when the guys that are working on the Linux support for the Apple hardware, once they get support for the M4 upstreamed, then potentially I could even look at running Slackware on the Apple M4 natively, or the Apple M series natively. It's not something that I'm interested in right now, but it would be kind of cool. But we'll see. Okay, so anyway, yeah, thanks again for your support on that. That's really appreciated. So let's begin. Okay, let's turn on the Raspberry Pi. See where we are with that. Hasn't been turned on in a while, so I don't know what it's running. Probably the standard Slackware is my guess. Oh, definitely, yeah. Okay, so that's running the regular Slackware kernel. So now I'll transition to the Raspberry Pi Kernel Fork kernels. So I've logged into the Raspberry Pi 4 remotely, and you can see that we're currently running Linux 6.12.24, which is the mainline kernel from kernel.org. So this is the upstream official Slackware ARM kernel. And you can also see this one here. So TTY shows you the remote, the remote terminal interface that we're connected in from, and you can see here it's TTY-S1, and we're running on a Raspberry Pi 4 Model B. Okay, so we have serial access working. So what I'm going to do is transition this machine to run the Raspberry Pi Kernel Fork packages. Now, if you don't know what I'm talking about, if you go to arm.slackware.com, go to installation guides on the left-hand side, find currently just Slackware ARH64 current because we don't have a stable release yet. And if you look for the Raspberry Pi 4 guide like that, and then if you scroll down a bit on the right hand side, you'll see where it says switching to the Raspberry Pi Kernel Fork. Click on that, click on the link where it says provide replacement packages, and it explains here, it gives you a little bit of background and tells you how to download them and how to install them and all that kind of stuff. The only reason why you'd want to use the Raspberry Pi Kernel Fork packages, which basically means it's a Slackware kernel, but it's built from the Raspberry Pi fork. So they've copied the Linux kernel and they've modified it, they've made bug fixes, added support for extra hardware and all that kind of stuff. And they've configured it, they've supplied a default config that works for the Raspberry Pi version. In this case, it's the Raspberry Pi 4. So the only reason you want to do that is because the official Linux kernel doesn't have the support for your particular bit of hardware you've got connected to it, or the support is buggy or something like that. Other than that, there's no reason to use these at all. But unfortunately, it's just the case with the Raspberry Pi that the support for their hardware there's quite a bit of a lag between them developing the support and pushing it upstream. Eventually it gets there, but it takes a long time. Okay, so that's that out of the way. So I'm going to transition to this Raspberry Pi Kernel Fork, and I'm going to pick the Raspberry Pi 4 kernels. So you have to be careful here that you pick the right kernel. So in my case, I'm just selecting the RPi 4 because that's what my machine is. It's the build tag here that identifies which hardware model or which version of the Raspberry Pi these particular packages target. Okay, so we're using the Slackware upgrade package tool to transition to this. And again, all of this is documented in the guides that I showed you. As part of the process of switching between the official Slackware kernel and the Raspberry Pi Kernel Fork package, you will see all of this noise here, these errors. Again, this is documented in the transition guide, but don't worry about it. This is normal. It's just because the module, it's just basically because these modules aren't configured in the Raspberry Pi kernel because presumably they're not needed. Well, I know for a fact that some of them aren't needed, but that's the error. Even though they're surfaced as errors, the process is actually completed successfully, so you can just safely ignore these. So there we go. So the packages have now been transitioned from the official kernel to the Raspberry Pi Kernel Fork. And so what we need to do now is to reboot. Reboot and press enter. So that logs me out, but then we can follow it along over the serial console here, at least to a certain point. So it's currently rebooting the system. And so you can see here on this is the monitor of the Raspberry Pi. So that's connected over HDMI. And you can see here, this is the output from the serial console of the Raspberry Pi. So you can see here, it's currently, you probably can't get it all on at once, but well, maybe I can. But you'll see here that we have lost serial output. So you can see on this screen that we no longer have any serial output. We just don't have any control or visibility over the serial port, but we do have access to the console. So what I want to do now is test the changes that I've built, which will be folded into the installer, into the Slackware installer, which will run in the post-installation phase and reconfigure this Raspberry Pi so that it works correctly with the Raspberry Pi Kernel Fork. This is also one of the errors that you'll see. So by default, the init tab for the Raspberry Pi is configured to use, I think it's TTYS1, which is the standard in the Linux kernel config, but for the Raspberry Pi, I think it's TTYS0. So every 5 minutes, this error will repeat. It's harmless though, it just means you can't use the serial console. And so that's one of the other things we're going to fix. Okay, so I've SSH'd into the Raspberry Pi, and I've been working on this script here. This script will be added to the Slackware installer, and all it really does, it runs in the post-installation phase, so once all the packages have installed and a few other things have been configured. It's launched at that point, and what it really does is just configure a few things so that they work correctly with the Raspberry Pi Kernel Fork. So what I want to do now is test this script to make sure that the configurations work, and then reboot the Raspberry Pi and make sure everything's how I expect it to be. So I'll just walk you through this script. I'm not going to get into detail of this really, it's very simple. First of all, it just checks that the hardware model type is a Raspberry Pi. If it's not, then it silently exits. We don't need to make a fuss if this script isn't running on a Raspberry Pi, because the Slackware installer is generic, so this will run on all hardware models. So we don't need to cause any, flag anything up there. So we just exit silently if the hardware model that we detect is not a Raspberry Pi. Next, we append, we just append this here that I've selected. We append these kernel parameters to the kernel command line, and we edit the U-boot. Ooh, that's broken. We edit the U-boot configuration. Okay, I've checked. So that should be a variable. So that would be this. Oh, well, I can use that copy there. Yeah, so we just check whether the file exists. Usually it should on a Raspberry Pi, unless you've diverged manually from the Slackware, the standard Slackware presentation. So we check if the bootloader, U-boot bootloader config exists. If it does, it appends these parameters here to the kernel command line. And this bit of sed here just chooses the correct line, because there are various append lines in there, but they're all commented bar one by default. So it just makes sure that the one that's editing is uncommented. Then it just checks if you have an init tab. You really should have one, but it checks anyway. And then modifies, it exchanges TTYS1, which is the standard serial port name for the mainline Linux kernel. It switches that with TTYS0, which is what works with the Raspberry Pi kernel config. And then finally, it creates or appends to the Slack package blacklist file the Slackware official kernel packages. The reason why it does it, you may not be using Slack package, so it checks if the config file exists. But if you are using Slack package, you need to mask these out. You need to blacklist the standard or the official Slackware kernel packages, because otherwise, when you perform an upgrade, it'll replace the Raspberry Pi Kernel Fork packages with the normal versions, the standard versions, and then your system won't behave as you expected it to. So we blacklist those up front, and then there's a bit of information in there just explaining why that's happened. Okay, that's it. So what I want to do now is copy or run this file on the Raspberry Pi just to make sure it works before I fold it into the installer. So mutley is the one, so mount HD, arm slash, where is it? Arch source installer. In the installer, this actually will be living in user share /HWM configure. I won't get into all of that now. If you're interested, you can go to the Slackware ARM development page on docs.slackware.com and then have a look at the Slackware installer here. And I think I've explained it here about these post-installation scripts, so you can read about it there if you're interested. So what I'm going to do is just modify that kernel fork script a little bit. I think actually it's fine. Okay, so this script is actually designed to be called from another one where these variables are set. So HWM would already be set by the caller and by the parent. And this TPX value refers to the location, it refers to the mount point of the operating system's root partition. And again, that's set by the parent already. That's why they're not defined in the script. I have defined this here just to test it because it needs to be set, otherwise it won't work. But in this test, this variable here, tpx, will expand to nothing, in which case the value of this file will just, the value of this variable will just be / etc. That, it'll just be that. So this should work. I think that's it, right? Yeah, and I'll just check the blacklist file as well. Just check that. I assume there's nothing in there. Yeah, there isn't. Great, okay. So if I just run bash RPi. Oh, actually, I'll tell you what, let's just confirm as well. So grep S0 init tab. Right, so currently we've got ttys1 on the init tab. Grep append boot x Linux. Okay, this is the line here that the script will modify. As you see, there are a few append commands here, but they're commented. So this is the version that's uncommented, and this will be edited. So this is what I think. That's it. Yeah. Okay. So let's run that script. Hopefully, it breaks. Hopefully, it's not supposed to break. Okay. Line 48. 48. What have we done here? Oh yeah, that's why, because it's got the. Oh, I'll just move that over there. There we go. Right, let's try it again. There. Okay, cool. So let's see what it did to that. Did it append the lines to the bootloader? Yes, it did. Did it do it correctly? ORQ poll. Yes, it did. Is it 112? Blah 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 blah. Yep, that's good. Okay, so then what are the other ones? Grep init tab. Has it switched it? Yes, it has. From ttys1 to ttys0. Yes, it has. And then finally, blacklist. Here we go. Oh, I should probably add a little bit more. Yeah, maybe I'll add a space there actually, just because I don't like the. Yeah, I prefer having a space there. Okay, or rather an empty line. Okay, right. So that looks good. So if we once again move back to the serial interface. So this is this window here is connected to the serial interface of the Raspberry Pi. So let's now reboot the machine. So I'll just prepare that. Okay, so back to watching the monitors. Okay, so there's my reboot command. So let's just press enter. So this is over SSH at the moment. So let's just press enter on the reboot, switch to the serial console. So we can see the machine here on the Raspberry Pi's monitor. So the machine is rebooting. And if we step back a little bit, we should see some output on the serial console in a moment. There we go. And then if we step back, you can see a little bit there. So we can see the machine is booting on the right hand side monitor. Now, do we have access? Yes, look at that. So we've got access to the serial console. Cool. And we have access still on the monitor, which is good because I didn't change any of those settings. So I did expect that to work. Perfect. Okay. We won't get that error message that we saw before about the init tab 5-minute respawning warning, because that's been fixed, because we can now log in over the serial port. I wonder though, that's made me wonder, can I actually log in over the serial port? It's possible I can't. Oh, I can. Good. Okay. I just wasn't sure if the because the access control for the serial port is configured here. So if I hadn't got ttys1 in the list, then I wouldn't be able to log in. Off the top of my head, I think one of the packages sets these up by default. Now that we've got that working, all we need to do is build the new kernel. Okay, so we've tested that. It all works as planned. So all I need to do now is delete this from here. and it's done. So we're editing the init tab, we check that. Bootloader, we check that. Blacklist, yeah, I checked that. Cool, okay. At some point, this script may need to handle different variants of the Raspberry Pi, but as far as I know at the moment, these settings all apply to both the Raspberry Pi 4 and the Raspberry Pi 5. So at some point it may need to, adjust the configuration depending on the Raspberry Pi variant, but at the moment it's fine. As it happens though, I'm not going to release this installer variant for the Raspberry Pi 4 because there's no need, because the Raspberry Pi, we already support the Raspberry Pi 4 using the generic standard Slackware installer. The only difference is it's packaged for the Raspberry Pi, the Raspberry Pi 4, but other than that, it's the same. So it's only for the time being, it's only going to be for Raspberry Pis that aren't properly supported in the upstream kernel, which currently, at the time of making this video, is the Raspberry Pi 5. So anyway, at the moment, I think this script is all in good condition and it's ready to go. So all I need to do now is build a new kernel. And when I build the new kernel, the Slackware installer will be rebuilt as well, and it will contain this new plugin, this new post-installation configuration script. So where are we with the kernel? So where are we with kernel? Oh yeah, great, 6.12.35. So let's arm that one. So Slackware upstream has already moved to .35, so I just grab it from the Slackware source tree, because then it saves me having to verify the GPG signature and all that stuff, so I can just pull it directly from the Slackware tree. Then we do source update like that, and this will update the kernel configuration file. Occasionally there's a few options to set or check, but usually there's nothing, minor update. Okay, so there were no configuration changes to set, which is expected. Okay, so let's, oh yeah, well, so currently the machine is actually building the latest round of packages. I forgot about that. So it's been doing that for 2 hours and it's currently on pass number 2 and it's building Rust. Once that's done, all I need to do is just build the new kernel, and then the installer will be built subsequently. All right, well, that's another piece of the job done. I hope you've enjoyed the video. If you have, let me know. If not, don't need to know if you didn't enjoy it. That's fine. If you did, you can let me know, and that's all very nice. All right, and again, thank you very much for those of you who support the project, that keep this thing running. I really appreciate it. All right, take care everyone, and see you in the next video. Adios.